Yeah. Uh, Hello everyone. So we'll discuss about some questions and solutions that were asked in your daily quiz for engineering mathematics course. And I think this quiz was given to you in the second week of June. Okay, so this is pertaining to week 2 of June 2025. Okay, so we'll discuss those questions and try to understand some important concepts. Okay. So let's get started. The first question is on complex integration. So they are asking you to evaluate this integration where the closed contour C is nothing but a circle of radius 3 and centered at origin. Okay, so this is a standard contour that they give usually in these kind of questions, especially for GATE exam. So this is a circle of unit radius, radius equal to 3 and centered at origin. So this will be your 3 and this is your minus 3. Okay, and now you are supposed to identify the poles. Okay, so poles are nothing but the z values at which your integrand is going unbounded. Okay, so if you look at here, in the nature of this integrand, it is 1 by z into z minus 1. Okay, so there is a simple pole at z equal to 0 and at z equal to 1. Okay, so what is simple pole? So simple pole means the order is 1, and then there are repeated poles of higher orders. That is not needed here in this question to solve, but typically depending on the nature of the pole, the formula that you use to calculate the residue changes. Okay, so we have discussed all these things quite extensively in our regular classes. So if you have attended those, you should be able to solve this. Otherwise, you can revise it. Okay. So before calculating the residue, one thing that you should make sure is the poles must be inside your contour C. Okay. So z equal to 0 is inside your circle of radius 3. Similarly, 1 will be somewhere here, right? So that is also inside. So you have to consider residues at both the poles. Okay, so therefore the answer will be, using the residue theorem, is nothing but integration along this contour of nature, that mod z equal to 3 dz by z into z minus 1 will be equal to 2 pi I into sum of the residues of all the poles inside the contour. Okay, finite number of poles must be there. So first of all, you are supposed to evaluate residue at z equal to 0 and residue at z equal to 1 and then add them. Okay, so since these are simple residues, or simple poles, uh, the residue formula is straightforward. No need of doing any differentiation or anything. So you just have to multiply by z minus that pole with the integrand and then take the limit. Okay, so here basically you are supposed to multiply by z to the integrand, which is 1 by z into z minus 1. Okay, so z gets cancelled, and if you put z equal to 0 in this limit, it is just minus 1. Okay, so that means the residue at z equal to 0 is minus 1. Similarly, if you calculate the residue for this integrand or this function, integrand function at z equal to 1, since these are simple poles, you just have to multiply it by z minus that pole. So here it is 1 into the integrand function. That will be z into z minus 1. Okay, so this z minus 1 terms get cancelled, and 1 by z, z equal to 1, so that is just 1. Okay, and you are supposed to add to these two residues and then multiply by 2 pi I. Okay, but if you see, that is minus 1 plus 1, that is 0. So therefore, this integration of z minus 1 in the denominator on this closed contour is 2 pi I minus 1 plus 1. So that is 0. Okay, so the answer should be 0. And is there any option like that? Yeah, so the correct answer should be option C. And it is matching with your answer key as well. Okay, so this is a coincidence. Okay, the answer will not always be equal to 0. So don't assume those kind of things. Okay, otherwise students get confused between Cauchy's integral theorem and this because both of them may give answer 0. No, don't mix the things. The answer is 0 here. It's purely coincidental. Okay. Now let's go to the next question. So they are asking you to find the complex conjugate of this complex number. Okay. So they have given you a complex number. Let's call it as Z minus 2ixy plus 1. Okay. So typically speaking, complex numbers, they have a real part and then imaginary part. Okay. And complex conjugate means you keep the real part as it is and you just change the sign of the imaginary part in the original complex number. That is called as conjugate of the original number. But this Z is not in a standard form, so we need to do some simplifications. So let's go to the next slide because that will be better. X plus iy whole square minus 2i xy plus 1. Okay, so just expand this bracket. It will be iy whole square plus 2ixy minus 2ixy plus 1. This term gets cancelled. And I square into y square. I square is minus 1, so this becomes x square minus y square plus 1. So if you look at this complex number, it's just a mere real number, no imaginary part, because there is no I term, right? So when you take the complex conjugate of this, there is no imaginary part, so there is no part to change the sign. So basically, its conjugate, typically denoted by z bar, will be the same thing because it's just a real number. Okay, so in this case, since there is no imaginary part, the given complex number and its conjugate both are same. Okay, so the answer should be x square minus y square plus 1, which is option A. Okay, yeah, and this is also as per your answer key. Okay, so in this question, I think first most of the students will do the expansion of the square bracket and solve this, but some of you might get confused in this conjugate part. Okay, so your definition or your concept should be clear. If it is clear, then you can do all these questions quite easily. Okay, so let's move on. Now the next question is, these couple of questions are slightly tedious ones. Okay, no worries, we'll just try to solve this because here the function is not that straightforward or easy. Okay, because w is given as some function of y minus x divided by x and all those things, and you are supposed to evaluate the partial derivatives, right? Because in the end you are supposed to evaluate this expression. Okay, so solving this question directly is not an easy job. It will be a time consuming process. So in such cases, the easier part will be to do certain substitutions. And what we can do, let's call this y minus x by x minus by xy as some u function. And if you see, you can further simplify this as 1 by x minus 1 by y. Okay, so therefore your u is 1 by x minus 1 by y. Similarly, put some v equal to the other term z minus y by zy, and then you can further simplify this as 1 by y minus 1 by z. Why are we doing this is because then it helps in doing the differentiation of w. So your w now just becomes functions of variables u and y, where your function u is nothing but 1 by x minus 1 by y, and your function v is nothing but 1 by y minus 1 by z, if I'm not wrong. Okay. So now it looks slightly less a scary function, but nonetheless it's not that easy to go forward from here as well, because you're in the need of first order partial derivatives of w. So let's find del w by del x first. Okay, del w by del x. That means we are just taking the partial derivative of this definition of w. So now you need to use this chain rule of differentiation here, right? Because f is not function of x only; it is function of x, y, z, right? Sorry, f is function of u and v. So and u and v are functions of x, y, z. So here, since f is function of u and v, you are supposed to use the chain rule like this. Okay. And if you understood or if you had figured out this part, the question is not that difficult to further solve. Okay. Del f by del u, you don't know, but del u by del x, you know, right? So, because we know the definition of u, right? So, you can plug these values. So, what you can do, you can write this as del f by del u into del u by del x. That will be minus 1 by x square. And if you see, v is not function of x, okay, because it's only function of y and z. So, this will be 0. So, therefore, your del w by del x is only this much. Second term goes to 0. And like that, you are supposed to evaluate remaining first order derivatives also. So if you do that way, let's do del w by del y. That will be del f by del y. Del f by del u into del u by del y plus del f by del v into del v by del y. Okay, so del u by del y, what is it? That will be 1 by y square, because minus minus will get cancelled. So you have del f by del u into 1 by y square, and v is also a function of y, if I am not wrong. Yeah, so that will be minus 1 by y square. Okay, so this will be del f by del v into minus 1 by y square. Okay, and similarly the last term of del w by del z, same, del f by del u by del z plus del f by del v to del v by del z. Okay, now what is del f? This term remains as it is. Del u by del z. See, u is not function of z, it is xy, so this term is 0. Okay, so therefore you don't need to write this. You can directly write del f by del v into del v by del z. Del v by del z will be 1 by z square, okay, because one negative sign is already there. And now what is the thing that they are asking is multiply by x square y square and add all of this. Okay, so from here x square del w by del x turns out to be minus del f by del u, right? So let's call this as equation 1. From here you are supposed to multiply by y square, the del w by del y term. So y square into del w by del y will give you del f by del u and minus del f by del v. So let's call this as equation 2. And from the del w term, from here you are supposed to multiply it by z square to del w by del z. That will give you del f by del v. Okay, so this is your equation number 3. And you are supposed to add all these three equations. Okay, so if you add them, you will have del square del w by del x, x square, del w by del y, z square del w by del z. And what will you have on the RHS? From equation 1 it will be minus del f by del u plus equation 2 will give you del f by del u minus del f by del v. The last guy gives you plus del f by del v. And if you see, these two terms cancel each other and last two cancel each other. Okay, so therefore this is your answer, which is nothing but 0. Okay, so this is how you should tackle these kind of questions. And is there option 0? Yeah, so option A is correct. So it matches with your answer key as well. Okay, so this is one of those questions which is, if you try to solve it in this fashion, you'll get the same answer, but you'll spend a lot of time basically in your solution. And in exams, these kind of questions are deliberately given in order to waste your time. Okay, so you should be careful. Okay, so the easier way is to do some substitutions and make it simplified. in a simplified form, you should write it, and then you can do the further simplifications. Okay, so very good question, and these kind of questions can be expected in your GATE exam as well. Okay, there these kind of questions are there to waste your time, so you need to be smart. Okay, nice question. So let's move on to the next question, where you have, oh yeah, this is also one of the even better question as far as competitive exams are considered. Okay, so in this question they have given you a z function, which is function of x and y, and it has three parts. Okay, first term is there, then there is a phi function term, and then in the last there is a psi function term. Okay, and you are supposed to evaluate the expression where this x square plus zxx, this means like the del square z by del x square. Okay, like that. So these are not subscript, these are partial derivatives. Okay, second order partial derivatives. Okay, and they have given you four options, one of them is correct. Okay. So if you try to solve this by this by taking the first partial derivatives of z and then again taking the second derivatives, it will be impossible. Okay, I mean, like if you have infinite time you can do it, but in the exam hall, if you try to solve it, better to leave these kind of questions if you don't know the trick. And the trick here is because this is a standard this thing, what you call, this is called as second order Euler operator, if I'm not wrong. Let me just check. Okay, because if you know that part, then you can solve this question pretty straightforward, very easily. But if you don't remember, because we have discussed this in our regular classes, it's not like it's a new thing for us. But if you don't remember in this exam, in your exam, you will be in trouble. Okay, so this operator is called as second order Euler operator. Okay, second order Euler. And this question is good, or one of the challenging ones, is because first of all, in your GATE exam, they don't go up to second order. Mostly they will ask you about first order Euler operator, and those formulas I have given you. Okay, so for example, like if your z function is homogeneous, so in our classes we use, I think, f as a f of xy, but that doesn't matter, it's a function definition. Is homogeneous, then you can write x into zx. That means del z by del x, first order derivative, partial derivative with respect to x, plus y into del zy, that means del z by del y, as n into z. Okay, what is n? Okay, so this is a homogeneous function of degree n. So that basically the degree of this z function is n. So this is your first order, what you call this, Euler operator. Okay, we don't call it as operator in our regular discussions, but this is pertaining to the first order terms. And if you are involving second order terms, okay, one second, if I'm not wrong, let's check the formula. Yeah, it is 2xy zxy plus y square zyy. It is nothing but n into n minus 1 into z. Okay, and so on and so forth. So in your GATE exam, mostly they tend to ask you this one. And there also, if you look at the definition of z here, I mean, they don't go up to this. Very rarely they have gone there. Let's say they are asking you second order also. Okay, so this is your second order Euler operator. Okay, I mean, this is the whole equation, not the RHS. Okay, don't get confused. Let me just remove this. Otherwise, some may think that RHS is like that, but it's the whole equation. Okay, and even if they, let's say, ask you the second order question, they don't give you complex functions. Okay, so here you have this function which is complex summation of 3 different functions, right? Usually they give you only some one function on the RHS in the GATE exam. Okay, so that is the max difficulty that I have seen so far, and that is why this question is one of the challenging ones, because it's not this complicated, usually speaking. Okay, you will not face this kind of questions. Very less chance you'll do that. Nonetheless, the thing is, here you should know one more thing to solve this question, that this Euler operator, they are linear operators, so you don't need to evaluate the whole RHS together. What you can do, consider this part as 1, this 3. So basically your z function is composed of 1, 2 and 3 functions, so you are supposed to evaluate this individually. Okay, so in this operator, this RHS n into n minus 1 into z, no need to evaluate for all 3 functions together, because these are not functions of same degree. Okay, for example, if you take this first function, okay, that is nothing but x square plus y square power n. If I'm not wrong, it is 2n divided by 2n minus 1, isn't it? So in this case, if you evaluate, this is a homogeneous function, first of all, with degree. Basically, again, you have to put x as lambda x, y as lambda y, and then you are supposed to write this as lambda power n into the original function. Okay, so that is the standard definition of homogeneous functions and how to find the degree of them. So if you do that exercise, you'll realize the degree is n here. Okay. Whereas if you consider the second function, which is nothing but, I think, x into phi of y by x, right? So here also this is a homogeneous function. Okay, and the degree here is, one lambda will come out, because if you put x as lambda x, that y by x term lambda cancels, x will become lambda x, so degree will become 1, lambda power 1. And the last function, which is nothing but psi of y by x, is nothing but homogeneous function, and here the degree is 0 only, right? Because when you put y as lambda y and x as lambda x, lambda cancels, so lambda power 0 is there in the multiplier, so degree is 0. So on the RHS you have 3 functions. One is having degree n, I mean all of them are homogeneous, but one is having degree n, one is having degree 1, and another is 0 degree. So in such cases, you are supposed to find the contribution in this second order operator from each term. Okay, so that is your final answer. So the contribution of each term on RHS in second order Euler operator will be nothing but, if you consider first term, the degree is n, right? So that will be n into n minus 1 into z. That will be your first. And here z will be not the whole thing, right? Z will be this function only. And the degree is, if I'm not wrong, the degree is 2n here, not n, because it is 2n. So this was a typo, it is 2n. Because lambda square, right? So that 2 into n comes out. Lambda power 2n comes out, so that is fine. So degree is 2n, not n. Okay, so this will be nothing but, see, this is the standard answer, but here the degree is 2n, so this will be 2 into 2n minus 1 into the original function. That will be x square plus y square whole power n into 2n into 2n minus 1. Okay, so this gets cancelled, and you only have x square plus y square. So this is the only contribution from the first function. Okay, second function, what is the degree? That is, degree is 1, so it will be 1 minus 1 into x into phi of y by x, but since it's 1 minus 1, it is 0. And third is psi function, right? Degree is 0 itself, so I mean whatever you want to write, you can write, but it is not contributing anything. Okay, and the final answer is sum of all. Okay, and final answer is will be sum of all, that is nothing but x square plus y square whole power n, because other two functions are not contributing. They may contribute for first order Euler operator, not second order. Okay, and that is your final answer, x square. Yeah, option C is the correct answer. Yeah. So you are supposed to remember that whenever you have such kind of things. First of all, in your GATE exam, they have not asked this question so far. Okay, where you have sum of 1, 2, and 3 functions. They only give you one function, and in that case, you are just supposed to use this n into n minus 1 into z formula. But here, since z has 3 parts, 1, 2, and 3, you are supposed to calculate the contribution of each function, 1, 2, 3, because each of them have different these things, degrees, and therefore they contribute differently. Okay, so it's not like you can consider whole function together and get the common degree. It won't work, right? Okay, and I'm skipping the part where you're supposed to calculate the degree because I assume that you guys know. If you don't know, it's a standard definition that f of lambda x. So for homogeneous function, like if somebody doesn't know this, maybe I just write it here. For homogeneous function, you can write f of lambda x and lambda y equal to lambda power n into f of x comma y. Okay, and this n is your degree of your homogeneous function. Okay, so do that exercise for all these 3 functions and you'll get the same answers. Okay, so this is one of the toughest questions that I've seen in your quizzes so far, because first of all, it's a rarely asked question. This second order Euler operator itself is a rarely asked, and in that also giving a 3 composite function on the RHS, it's a very rare thing. Okay, but I think you should take it in a positive sense. Even if you got this incorrect in your quiz kind of thing, it's fine. That's not your final answer, final exam. But if you understood this much, I think it is more than enough for your GATE exam at least. Okay. So yeah, very nice question. So with that, let's move on. So this is your final answer, because you are supposed to find the contributions of each term and then add them. Okay. The final answer. Now, the thing is, next part. Yeah, so let's go to the next question. Okay, but this was a very interesting question, very rarely asked. I'm glad that they asked. Yeah, so now let's come to the 5th question. So here you are supposed to find the surface area of a section of a solid cylinder. Okay, so they have not mentioned the limits on the height of a cylinder, so you don't know. You can assume that it goes till plus minus infinity, that's fine. But what they are not asking you anything about the cylinder. What they are asking you is the surface area of a section of a solid cylinder made by the plane x plus y plus z equal to 2. Okay, so this is a difficult question. I will be honest with you, because if you consider, so basically what you are trying to find out is some area like this. Okay, so if you take this projection on the xy plane, this will be a circle. Okay, so this will be a circle of x square plus y square equal to 4. So we all know how to find the area of a circle, but they are not asking you to find that. They have given you one plane. So this is the plane. Okay, so this plane is cutting this circle at certain cross section or section, and then you'll have such kind of slant area, right? So this area is what they're asking you to find. And unfortunately, there is, like, we don't teach these kind of questions in regular classes. The reason is they are not that frequently asked. Okay, what we typically teach is the arc length, the volume of solid of revolution, all those kind of formulas we give. But this is one of those questions which is very rarely asked, so we don't usually give the formula. But this is a formula based question. You can't do anything in your exam because it's a 3D projection problem. Okay, even if it is 2D, maybe you can do some cos theta, sin theta kind of things. But here, if you don't know the formula, I doubt that you will be able to solve this question. Not because anything about here this thing, but these are some of the formula-based questions. Okay, you are not. If you don't know the formula, you can't do anything. Okay, and the reason basically is that I mean, I'll give you the formula, and since it's a formula, it comes from somewhere, right? So yeah, I mean, again, I think this is one of the toughest quiz that I have solved so far, and you should be thankful for the people who made this. Okay. So here, to do this, you have two pieces of information. One is the circle in XY plane, and then the plane which is cutting this solid, I mean the cylinder. Okay, so we don't know where it exactly cuts, but you can guess, right? When you put x and y 0, that is z equal to 2. So, you know, like that. So you can take some idea, but to find the surface area, which is the point or the quantity that they want, you are supposed to use the following formula. So I'll give you the formula so that you understand. Okay. So the surface area of a surface z equal to some function of x and y over a region R is given as, let's say, some area as a double integral over that region R, and in square root you have 1 plus fx whole square plus fy whole square, and outside you have the elemental area dA. Okay, fx is nothing but first derivative of this function with respect to x, partial derivatives we are talking about. Okay, and since this is a formula, it has to come from somewhere, right? And there is a derivation behind it. We are not going into those things, but basically, see, if it is just a circle, you don't need to take this square root term, right? So in a sense, this square root term, this term, takes care of this stretching, okay? Because it's not a horizontal area, right? This is a slanted area, right? So this is a factor for slanting or stretching factor. Okay, how it comes, again, there is a derivation for it. No need to go into those details. Okay, but you should remember this formula for your exam at least. Okay, because if you don't, like, let's say you consider the stretching factor is equal to 1, then you are just integrating, and getting the area of circle, right? But that's not what we want. Okay, and basically, you use some magnitude of cross products of position vectors x and y and all those things to get this formula. No need to go there. Okay, so let's solve this. But now the question is, what is z, right? So in this question, they have given you the equation of plane, right? From here, you can write z as 2 minus x minus y, right? And that becomes your function. So therefore, the area that you desire, the area of this slanted intersection of circle, cylinder and the plane, is nothing but, okay, again I'll write the formula so that dA. So z is 2 minus x minus y. So what is your fx? That is nothing but basically del z by del x. So whatever is your function, you are supposed to take the first partial derivative with respect to x, first order. So that will be minus 1. Similarly, fy will be again del z by del y. That will be again minus 1. Okay, so therefore your area that you want is nothing but 1 plus minus 1 whole square plus minus 1 whole square into dA. So that is nothing but square root of 3. Okay, and then it is just dA. Okay, so now you see this dA means nothing but area of circle given by x square plus y square equal to 4. Right? So basically circle at centered at origin and radius of 2. Okay, so therefore the area will be root 3 into pi by 4 d square, right? Or just for the sake of simplicity, you can just write pi r square also. Radius is 2, right? So that will be 2 square. That is 4 3 pi. Okay. And what is there any option like this? Yeah. So option C is correct. Yeah, matches with your answer key as well. Okay. So the thing is, the main thing is here this stretching factor. Okay. Unfortunately, this is not taught in regular classes. The reason is this is not regularly asked also. I mean, this is the first time I am seeing anything like this for GATE exam preparation. But it's good. It's good that they are covering different types of problems. Because nowadays in GATE exam also 1 or 2 questions from maths are like this only out of everything. Okay. But yeah, if you are not able to solve this question based on our regular classes, it's fine. It's not your fault because this is that type of question only. You can't do much about it. Okay, if you don't know the formula. So it's a good thing that they have given this in your quiz. So take it in a positive sense. Okay, and remember this formula for your final exam also, so that if something like this comes, you are supposed to, you will be able to solve this. Okay. So let's move on. So now I think one more question is there. Yeah. So this is based on your Maclaurin series. So you should know what is Maclaurin series or Maclaurin series expansion. It is nothing but Taylor series centered around 0. Okay. So what is your Taylor series? That is the next question. I mean, you should know this, Taylor series expansion of, let's say, f of x about some point x naught is given as f of x equal to f of x naught plus x minus x naught into f dash of x naught plus x minus x naught whole square by 2 factorial. Then second derivative of f of x evaluated at x naught and so on and so forth. So for Maclaurin series, just check the spelling. Yeah, for Maclaurin series, you just take x naught as 0. Okay. Therefore, you can write f of x as f of 0 plus it will just be x into f dash of 0. And this will be x square by 2 factorial f double dash evaluated at 0, so on and so forth. Okay, so this is your Maclaurin series. Now, what they're asking you here is they have given you a function. So here f of x is e power a minus x. Okay, so the a minus x is the exponent. And now you're supposed to find the value of a, for which the coefficient of x power 20 term in the Maclaurin's expansion becomes e square by 20 factorial. Okay, so we'll do that, but just have a look at this. See, what you can do this e power a minus x Maclaurin series expansion as well. But the easier part is, since e power a is a constant, you can write this as e power a multiplied by e power minus x. And since e power a is a constant, it will be present there in every term in your Maclaurin series expansion. So basically, you are supposed to do this expansion only. Okay. So let's do that. So what do you need? You need f of 0 and the derivatives evaluated at 0 for your function. So when you have f of x as e power a into e power minus x, first of all, what is f of 0? That will be e power a, right? Because e power minus 0 will be 1. Then, f dash of x, that turns out to be e power a is a constant, doesn't happen anything to it, so e power minus x. And like that. Okay, so we are not going to solve everything, but you get the idea, right? E power minus 1 into e power a. Okay, and since e power minus x is a function whose derivatives, you know, are same after two orders. Okay. So what I'm trying to say is, see, this double dash f double dash x will be same as f x. Okay, we'll see that. That will be e power a into minus 1 into minus 1 e power minus x. That will be, so that means this is oscillating from e power a to e power minus e power a, and so on and so forth. Okay. So for 20, you know, if you take the 20th derivative of your function, it will be just e power a, because it is a even derivative, right? Second, fourth, like that. If it is e power 21st derivative, it will be minus e power. Okay, so this is fine. So that is first part. Okay, and they're interested in the whole term, the coefficient, right? So the coefficient of x power 20. Okay, coefficient of x power 20 term. It will be nothing but, it will be x power 20 divided by 20 factorial into this one. So that will be 20th derivative of your f of x evaluated at 0. This will be like this, and the derivative evaluated at 0 will be e power a. Okay, divided by 20 factorial. That comes from the formula. So therefore it will be e power a by 20 factorial. And what they are saying is this coefficient term must be equal to e power 2 by 20 factorial. Then, this e power a by 20 factorial has to be equal to e power 2 by 20 factorial. So if you compare the exponents, you'll realize that a has to be equal to 2. Then only this equality holds, right? So is there any option like that? A equal to 2? Yeah, so the first option itself is the answer. Right. So like that. Okay, so this is your option A. Okay, so this is the classic case where they are, asking you to evaluate the first of all Maclaurin series, and in this question they have asked you one additional part where they are comparing some coefficients of some higher order terms or higher degree terms. Okay, so again, you are supposed to remember what is Maclaurin series is. If you do that, I think you should be able to solve this question easily. Okay, so with that, I think we have covered all of the questions. Then we'll stop. Okay, so there were some interesting questions in this quiz. I think this was one of the toughest quiz that you might have solved so far. I mean, at least for a couple of months I am solving this, so amongst that I'm talking. Okay, so yeah, interesting questions, and I hope this solution discussion will help you. Okay, so with that I'll stop here and see you next time. Okay, bye.